Good morning, everyone. Thank you for joining our session. I really appreciate that you took out your time from this wonderful weekend. Today is Sunday, a warm Sunday, it looks like, for the folks in Mumbai. Thank you for joining our session. So, as you all know, we are back with our interesting sessions around serverless. And this is the entire series, which will constitute of 4 sessions. And this is the first session what we have. The whole idea is to ensure when we talk about serverless, it's not just Lambda, it's not just step function. There are many other services, and we want to give you the taste and the flavor of all those different offerings provided by AWS under serverless services. So all of these 4 sessions, each sessions will be at an interval of 2 weeks starting from today, and we'll try to ensure that each session is very interesting, covered by good panel speakers who are expert, renowned in the market for talking about the serverless services. And today we will be talking about our first session, which will be overview on Fargate, SAM and StepFunctions. And this session will be given by Aishwarya Gupta. She is the cloud engineer at Quantiphi. Before I jump and pass on the control to her, let me quickly introduce her and talk about this, what and how she's passionate talking about the serverless. So you would be knowing Aishwarya a lot. She has been part of different other sessions so far, where you talk about the entire solution architect bootcamp, which was done a couple of months back, as well as you talk about the user group Mumbai event she talked, where she participated talking about the security. And again, she is back to deliver an interesting session talking about the serverless. So far, I know Aishwarya very well. She's one of my colleague in my company, Quantify. So I was working in and out, and she's the best person when it comes to Fargate, step function, and the serverless deployment. And we have Ash here. Let me get on the stage. Hi, Aishwarya. Good morning. How are you doing today?
Hi, good morning. I'm doing good. Glad to be here. Thank you for the introduction, Sanchit.
Thank you so much for accepting our invitation and helping our audience to talk about what exactly the serverless and how serverless can help, right? And helping us to go deep dive, talking about this topics what you have today, and helping us with a demonstration. So, guys, as I said, please stay with our session. Follow us, subscribe us. We'll have 4 sessions of series, and as well as each session will be backed by a quiz at the end of the session, which will have some good rewards in forms of AWS credits. So this will be an interesting from technical perspective, as well as learning, as well as some rewards. So stay tuned. Don't leave. It's Sunday, so you guys can spend some good time for your learning. With that, I'll pass it on to Aishwarya to go share a screen and go with the presentation. Ash, over to you.
Hi, good morning, everyone. So, as Sanchit already introduced, today we'll be going through the overview for Fargate, SAM, and step functions on AWS. So, these are some of the most popular serverless functionalities that AWS provides. So, let's directly jump into AWS Fargate first. As Sanchit already introduced, so we can skip over this. So let's talk about AWS Container Services with Fargate. So let me give you a brief introduction on containers. Basically, containerizing our application is packaging into a container, that is packaging it with its own dependencies, with its own requirements, libraries, and everything, such that it is separated out, modularized, and independent from the hardware on which it is deployed, such that our application has no dependencies when it's deployed on different environments. So when we containerize our application, how do we deploy it on cloud? So for this, AWS has provided us with certain container orchestration tools. Those are ECS and EKS, namely, so Elastic Container Service and Elastic Kubernetes Service. Both of these services are container orchestration tools. That means AWS helps us manage the life cycle of our containers. That is, using these tools, we can provision our containers, we can manage them, we can also scale them. So all of this happens on the control plane for both of these services, and they are managed services. So what is the difference between both of these? So for Elastic Container Services, all the services that are inclusive of it are AWS specific. So it is an AWS native tool. It uses all the AWS native power to deploy our applications on containers, whereas EKS is a managed Kubernetes cluster. So the control plane consists of master nodes and Kubernetes master processes running on it. But to orchestrate your containers, you really need an underlying server on which you can host them. So what are these server options that both of these container services provide us with? So we get two server options. We have EC2 and we have Fargate. Both of these are AWS native services, and the difference between them is EC2 is when the user has the control. So the user has to provision the servers, the user has to manage the servers, manage their life cycles, and also troubleshoot them when required. Whereas Fargate is a serverless option where we delegate the control to AWS to manage our service so we can focus on our containers and our application. So, what is the difference now? What is the difference of using our containers with EC2 or Fargate? And how is Fargate a serverless option better than EC2? Sorry. Okay, so when it comes to EC2, EC2 is more of a virtual machine. So it is an option provided by AWS where we can provision a virtual machine whenever we require, and we can decommission it when our use case is complete, and we pay as we go for it. But with provisioning a virtual machine, there comes an overhead of an operating system that we need to manage, that we need to patch timely, as well as we need to manage the scaling of it. So if you deploy an EC2 instance and you deploy your application on that EC2 instance, you need to manage the scaling for your application. So if you want multiple EC2 instances, you will have to manually create the infrastructure, that is a load balancer, an auto scaling group, a target group, where your application will reside. You would also have to manage the logs and monitoring for your application that is hosted on EC2 manually. When it comes to using EC2 with container services, although the provisioning, the scaling, all of this is managed by container services, we still have to manage the EC2 service itself. So we'll have to create the EC2 instance. We have to connect it to our ECS cluster, which is a logical grouping of our servers. So we'll have to connect our EC2 instance with our ECS cluster. We have to set up the VPC subnets, the availability zones for our servers, as well as we have to manage the operating system, which is the patching and the maintaining and the upgrading. It is up to the user to determine the type of instance we want, if we want a memory optimized or a compute optimized instance for our application, and also the class of our instance. So the user has to approximate that themselves and select these options when we use EC2 with ECS. But what happens when we switch to Fargate? So Fargate is very uh, beginner friendly. So here we delegate all of this maintaining of the server to AWS. AWS does this for us, and we can directly focus on the very basic unit of ECS, which is a task. So task is a set of containers that is hosted. Now it is abstracted from us where these containers are hosted. This is completely managed by AWS. All we have to focus on is provisioning those tasks. So underlying infrastructure we don't know about. The launch and run containers we can do without having to know which server it is launched on. Users don't need to worry about the instance type or class or anything like that. We can directly specify our memory requirements, our CPU requirements, and based on that, AWS will provision a server for us. So this makes it very easy for us to manage our container services using Fargate. Since it's serverless and completely managed by AWS, we can directly go and provision our tasks and run our application. So this is what happens when we use Fargate instead of EC2. So as we see for an ECS task with EC2, there is an extra unit that we need to manage, that is the EC2 instance on which the ECS agent is installed. So we need to manage that EC2 instance on which our tasks are running. But when we move on to Fargate here, as we can see that instance or that server that we previously needed to manage is gone now. It is not visible to us and it is completely managed by AWS. So now that we understand what Fargate is, let's talk about some major features of Fargate as well as some features that we can still leverage that we could do with EC2. So the first one is resource-based pricing by task size and per second billing. So even though AWS Fargate would come with some cost, it is still pricing based on the size of the task. So the user just has to define the memory and the CPU for a given task, and based on that, user would be billed per second of compute. Then there are flexible configurations for CPU and memory combinations. So there are over 50 CPU memory combinations a user can define for a task in ECS with Fargate. Then there is networking with VPC features. So now, as we know, we don't have to provision a server, but we can still use the VPC features that are provided by AWS. So we can use VPC, we can use subnet, we can use security groups, and as well as IAM with our ECS service that uses Fargate. So it helps us leverage various security and monitoring that comes with our VPC. We can still use the load balancers with our ECS service. So we can still configure an application load balancer or a network load balancer in front of our Elastic Container Service, even if we are using Fargate. Then permission tiers. So as we know previously, we with EC2 we have something called an instance profile. So with EC2 we connect an instance profile that gives our EC2 permissions to operate inside the AWS environment. Here, even though we don't provision a server, we can still define a task IAM role or an instance role that allows our task to communicate or to operate on the AWS cloud. Then container registry support. So similar to with EC2, we can directly pull our container image from Docker or from ECR, which is AWS native, and deploy our application from a container image. Then there is logging and visibility of CloudWatch logs and metrics. So with ECS with Fargate, we can also monitor centrally our container service centrally using AWS CloudWatch logs and metrics. So these are all the features that ECS provides with Fargate. These and there is more to come. So now that we talk about serverless, there must be some trade-offs. So if we are delegating all the control to AWS, there would be certain limitations that would come with it. So based on use case, it is important to understand what suits our situation more. So if we are using EC2, with EC2 we have more control. So we have if we want more fine-grained control on our servers, if our application is more specific to that, then we can use an EC2 instance where we can manage starting from provisioning the service to scaling the service to logging and monitoring to troubleshooting. Everything can be managed directly by the user. But what if we want an application with multiple EC2 services? How do we manage that? In that case, we can use Elastic Container Service with an EC2 server, where all of the provisioning, scaling, and troubleshooting is handled by Elastic Container Service. But we still have a server in the backend that we can manage, that we can patch, that we can upgrade. And we can select a specific class and memory for our server. Then comes to the extreme right of the diagram, then comes Lambda. So when do we use Lambda? Lambda is used when we want just a very specific, a very abstracted environment, which is very function specific. So how Lambda works is you just directly upload or deploy your code, and whenever you invoke your Lambda, that code is executed. You don't know where it is executed. You don't know, you don't define the load balancer configuration. You don't define the auto scaling configuration. All of that is handled by AWS. All you have to do is upload your code and invoke it. And it can run multiple times. It can run parallelly as well. So that's where Lambda comes in. And Lambda is also for very short running tasks. So it is not for long running or background service. It is for maximum 15-minute long running tasks. So that is where Lambda comes in. Fargate comes somewhere in between both of these. Fargate gives us the opportunity to manage our container service, as well as it takes away the operational burden of managing our servers and patching our servers. So Fargate is somewhere in the middle of both of these with the most optimized list of pros and cons. So in most of our serverless use cases, we can go for Fargate. So next, before I move on to the demo and the walkthrough for the Fargate, are there any questions? Okay. So let me walk you through the console for ECS and take you through all of the options that we are provided by AWS for configuring a Fargate cluster.
Aishwarya, sorry, there is one question.
Yes.
Where does ECS comes in terms of operational burden? I think you already covered up, but this is one question which you have.
All right. Okay. So let me move on. Yes. So this is, let me just go through the homepage for ECS. So while this is loading, these are our clusters. This is the homepage for ECS. These are our clusters. Clusters are nothing but a logical combination, logical grouping of our servers on which our containers would be hosted. So here I've already provisioned a cluster. I'll just show you how to provision it. It's very simple. So AWS already provides us with certain templates that we require for our cluster. So here I just, for use with Fargate, we have this cluster where we have just networking only. So I've just used this template. We can also have an EC2 plus Windows template or EC2 plus Linux template. So if I move on to the next step, all I have to do is define my cluster name and enable or disable CloudWatch logs insights. Since this is Fargate, it is not asking me about EC2 anywhere. So this is my cluster currently. As you can see, there is nothing provisioned here right now. So what is the next step? How do I provision Fargate? So the next step would be defining my task definition. What a task definition is, it defines how containers are hosted, how containers would be managed if there is one or multiple containers inside our task, and if there are multiple containers, how do they communicate with each other, what ports do we need to open, and etc. So here I have already defined a task definition, but let me show you what all options come when I go for defining a task definition. So here, as you can see, AWS has made it very simple for us by providing us with a template for Fargate. Here we can also use on-prem servers with ECS. For that also, AWS has provided us with a template. So currently we're just going to go with Fargate. So the first option is the name of the template. It requires compatibilities with Fargate. Then there is something called a task role. So this is an IAM role that we can use for sending out requests to other AWS services. So here we will define all the permissions that our task would require to communicate with other AWS services. So I would choose the ECS task execution role. Now networking mode. So by default, for Fargate, ECS provides us with a networking mode called AWS VPC. Operating system family. So for Fargate, we have three options. There is Linux, there is Windows Server 2019 Core, and 2019 Full. There are different limitations and different advantages of using any of these. Currently, I'm just going to go with Linux. Then there is task execution IAM role. So this role would help our task to pull container images. So this is a different role from the one that we saw above. This would help us to pull the container images and publish logs to CloudWatch. So here for me it is the same. So I've selected the same one. Then there is task size. So as I explained previously, with Fargate, we don't have to define a class or an instance type for our ECS. We just have to define how much memory we want and how much CPU we want here. And based on that, AWS will provision a server for us. So here you can see there are multiple options for memory. And for each of these options, we have multiple options for CPU as well. So as you can see, based on the CPU size, the memory size would have some limitations. So the valid memory range, as you can see, for one CPU is 2 GB to 8 GB. So for one CPU, I can have a memory as small as 2 GB and as big as 8 GB. Similarly, we can choose multiple combinations of memory and CPU based on our application. Then here we can add a new container to our task. So container definition, we can give here which image we want to pull for our container. That is, we can give a repository URI for ECR or for Docker here. And we can define the memory limits for our container. So it is a soft limit, it is not a hard limit. And there is some recommendation also provided by ECS for web applications. So we can choose accordingly. And here, as I mentioned, we can define the port mapping for our container. So which port needs to be exposed for our application to run. As well as there are some advanced health check and environment variables that we can define here. But for now, we are going with the default values for all of these. We'll just define these values here. So once we define our container definition, we directly go and we create our task definition. So as you can see, I have a task definition here and it is a version 1. So as you can see, our compatibility is Fargate, and for CPU and memory, I have chosen these values. Plus, there is no constraints on task placement, and I have a container definition as well. So my application would be running on the port 5000. And similarly, I have exposed this port on my security group. All of the other options are by default. So this is my task definition. Now I can go here and I can run my task. So launch time would be Fargate. Operating system would be Linux. Platform version latest. Cluster I can choose from here, as I previously created a cluster, so I'm going to choose my cluster. And number of tasks would be 1. I can choose my VPC from here and I can provide multiple subnets for multi-AZ deployment. So I have 2 public subnets. So I am assigning 2 public subnets to my task. Auto assign public IP is enabled, so I can access my application online. And this is my security group. So currently it is open to the internet. And I run my task. So this will deploy our task inside our cluster, which is serverless demo. But the difference using Fargate is we didn't have to provision our servers anywhere and we don't have to manage our servers anywhere. Here, since I have deployed a task directly, if we go to services, it will be empty. But if we want our tasks to be managed, that is, if our container exits without a reason, we need to spin up a new container. And we need to auto scale our tasks from 0 to X number of tasks based on the load. If we want to manage all of that, we need to create a service that manages our tasks. But currently, I have manually deployed a task here. So if I go inside my task, this is the task that is running. Right, it is currently running. So as you can see, there is one task running, and currently there is no CPU memory utilization. Let me just try to find the URL where I can access my application. Yep. So as you can see here, we have the logs using which we have started our task. And AWS has automatically provisioned our Fargate cluster for us. So since this would take some time, I will move on, and once my application is available, I will run it and show you that it is working fine. So are there any questions meanwhile?
Yes, Aishwarya, I think there are a couple of questions from the audience.
Yes.
So the first one is, can you give some use cases for Fargate versus EC2?
Yeah, so it totally depends on your requirements. For example, if you have specifications for your application. So if your application was already previously running on EC2 and now you want to migrate it to a container service, you would have some EC2 specifications that you already had, and you don't want your application to lose compatibility when you move to ECS. So in that case, you would use ECS with EC2, where you would be able to define and manage your EC2 instances that are running behind ECS and give the same configurations that you had previously for your application. Whereas for Fargate, I would say that if you are deploying your application which is new and you don't want to have the overhead of maintaining a server, all you want is a container orchestration service where you have your image for your application defined and you just want to directly deploy it on ECS, I would suggest we go for Fargate, where you don't have to really go into the nitty-gritties of defining the EC2 server and the various options for it. You can just provision a task and define what amount of memory CPU your task requires and directly deploy your application.
Thank you. I think there's another question from Shri. How is a task role different to an instance role? Which one would be recommended option?
Yep. So there are two things here with Fargate. There are two things. One is the rule that we require to pull the Docker image and to deploy it on our container. And one role is when your container is already running on your EC2 instance, and you want your container to interact with multiple AWS services. So, for example, if your application is sending out notifications using AWS SNS or accessing a database in the backend, DynamoDB or RDS, then you would require an instance role, where you would define all the services your task could interact with. And when your application is running, all these permissions would be used for your application to access all of these AWS services. So there are two types of IAM privileges that your ECS would require. One is to pull the Docker image and deploy it, and another is to interact with other AWS services while the image is running as a container.
Cool. There's another question. What we have is, can we compare task as a pod in EKS?
Yes, it is similar. So, let me show you. So, this is basically the hierarchy in an ECS cluster. There is an instance. In our case, it would be Fargate, so it is abstracted. On this instance for EC2, there would be a ECS container agent that would be installed. Then there would be a service. So, service is a logical unit that manages our tasks here. So these tasks, the deployment, the troubleshooting, and the redeployment, all would be handled by a service and defined in a service. What a task is a logical unit that would contain and that would manage one or multiple containers, Docker containers. So a task definition, we define how those containers can interact, how those containers are deployed. So all of this is done inside a task definition, and then there is the most basic unit that is a Docker container that is running individually inside a task. So basically, our application is running on the container, but all these units are used to manage our container service and orchestrate it. So yes, it is comparable with EKS.
Thank you. Last question. I mean, there's one more question. What we can see is Fargate cloud agnostic. Is it? I mean, when you say Fargate can help my from app migration standpoint, is it easy to take the Fargate application to other platforms?
Yes, so it is similar to going from a completely managed service to a virtual machine. So, for example, if you are deploying your it would just so if you start with Fargate, it is very user friendly, it is very beginner friendly. So if you're just starting with AWS, if you're just starting with container services, I would suggest you go with Fargate. But as you get more as you want to get more grained control on your application, you want to manage more things by hand, and you want to take that control from AWS, you can move to other services such as EKS or ECS with EC2. And that would be it would be obviously easier to move as Fargate has the least minimum configuration possible, and as you move forward the configuration will increase, but there would be very less dependencies as you move from Fargate to other services, since Fargate is completely managed.
Cool. Thank you. And also to add what Aishwarya just mentioned, right? If we go in the constructs of Fargate, there is a basic at the bottom is a Docker image. That Docker image will have all your configuration of your application, other stuff, which is the Docker image which you can take, maybe running in your on-prem system or in your laptop. So that's how you can make it more reusable and it's required.
All right.
So yeah, I think there are a couple of more questions. For sure, we can take it up uh, in the remaining session. Yeah.
All right, sure. Yeah, so I think that is all we have about Fargate. So moving on to our next serverless option after the demo. Yeah, so as I previously explained, this is what I'm actually doing in my demo. So I have a file in ECR that I'm pulling onto my task and deploying it. Currently, I'm doing it manually, but if I want my task to be long running, I would need a service there that would manage my tasks and provision them and manage the troubleshooting of my tasks. So here, as you can see, I have this repository from where I'm pulling my image. So here, if I go to my task definition, oh, let me just go back to my task definition here in my container. We can see that I'm pulling my image from ECR. So this is the image that I'm pulling from serverless demo repository. So I'm pulling this image directly into my container. All right. Moving on to our next serverless option that AWS provides, that is AWS Serverless Application Model. As we already know, AWS gives us multiple options for serverless services, that is Lambda, API Gateway, DynamoDB. But where do we and there are multiple options to deploy our applications, that is AWS CLI, AWS CloudFormation. But there is nothing, these are not specific to serverless applications. These are specific to all of the AWS services, any type of architecture. So SAM is a tool. AWS SAM is an open source framework that AWS provides specifically for serverless application deployment and management. It provides us with the shorthand syntax. So these are a set of commands. It is a CLI. SAM is basically a CLI that you would install in your system. And you could just use these shorthand commands, CLI commands, to directly provision your serverless application services. So you wouldn't have to go on the AWS console and provision them manually, or you wouldn't have to directly write a CloudFormation template. All you have to do is define a SAM template, which is similar, but it is more efficient. You can define a syntax for your APIs, your Lambda functions, and other event source mappings. So with just a few lines of code and your application code, you can directly deploy your application. And SAM is very easy to understand because on the back end, it is basically converting its syntax into CloudFormation. So when you use a SAM command in the backend, your services would be deployed using a CloudFormation template that you could also see on the console. But SAM provides an interactive enough environment on the CLI that you can monitor everything at one place. So as I've written here, SAM transforms our SAM syntax into a CloudFormation syntax while deployment. So there are two components of AWS SAM. There is a template specification file. There is a .yaml or .yml file, similar to what there is for CloudFormation. It is a specification file that helps you define your serverless application. So for example, there is an API gateway and there is a Lambda function. So you can easily define those resources in the SAM template specification with the syntax similar to a CloudFormation template. The template file allows you to operate on a single deployable versioned entity that is your serverless application. So it can be versioned, and you can use the SAM repository as well to maintain various versions of your applications and also to make it reusable. Then there is the SAM command line interface. So similar to what AWS CLI is, SAM CLI is a set of shorthand commands that we can use to compile, to validate, and to deploy, as well as to debug our applications that are specifically serverless applications on AWS. So as you can see, we can verify, we can invoke, and we can debug our Lambda functions that are serverless applications. We can also package them, and we can push them to the SAM repository as well, so on and so forth. So what are these commands that help us with deploying our serverless app? Firstly, we'll go through the template. So this is what the template looks like for SAM. It is very, as you can see, it is very similar to a CloudFormation template with a few syntactical changes. So as you can see here, I have defined a Lambda function. I have defined a handler for my function. I have defined a code URI as well as a runtime. So all of this defined in a template.yaml file as well as certain events. So I have an API gateway defined here. So using this path, I will be able to access my Lambda function. So when we deploy our SAM application, it changes the syntax to a CloudFormation template. So on the CLI, I have taken a screenshot of all the commands, all the basic commands that we can use with SAM. These are very easy to understand. What init would do, the SAM init would initialize our application. So if there is anything that we need to download from a repository, our code, anything like that, so if we do a SAM in it, all of it will be downloaded in our local repository. Then what validate would do is, if you have defined a SAM template, it would validate the template, it would validate all the permissions that you have to deploy that template. Build would build your Lambda code. So for example, if you have a Node.js or a Java code, it would build your code, package it. Local is a very interesting command. So using local, you can simulate your application locally. So you can create a local Lambda function where your application would be simulated. So you can see if there are any runtime errors or not, and if it is functioning properly before actually deploying it. So you using the local command, you can run your application locally for quick development, for quick troubleshooting. Then there is this option called package, where you can convert your application into a zip file. You can push it to an S3 bucket, or you can push it to a repository. Then there is deploy, as the name suggests. You can directly deploy your application uh, using CloudFormation template in the backend. So when we use the deploy command, we can go to the CloudFormation template console and we can see that our application is being deployed. Then there is logs. After your application has been deployed and you want to monitor the logs, you can use this command directly here on the CLI itself to monitor your application. You don't have to go to the AWS console, you can monitor it from right here. And publish would directly publish our packaged, here we packaged it. So it will publish our packaged template directly to the SAM repository. So there are multiple flags that we can use with all of these commands, as well as there are more commands that come with an advanced SAM, which we won't go into either. But my point is that with SAM, we get high flexibility and a central plane of control for our serverless applications. So let me give you a use case. So currently, famously, I think the most popular architecture for an application would be a load balancer, an auto scaling group, and some EC2 instance in the backend. But what about serverless applications? So a serverless application would typically consist of an API gateway, which is used for invocation of our Lambda functions. So if you want to invoke a Lambda function somewhere from outside, so we will hit an endpoint on our API gateway. This would call our Lambda functions based on the path. So if I have two paths, so there can be an n number of Lambda functions based on path. In the backend, these functions can be interacting with a DynamoDB table. So that is also a serverless type of architecture. This DynamoDB table could in turn be streaming data to another Lambda function, could be connected to S3 bucket, could be using SNS or SQS services for interacting with other serverless options. So this is what typically a serverless application would look like. And something like that can easily be deployed using SAM CLI. So before I move on to the demo, are there any questions? So no questions, I believe. I'll move on. So for my deployment demo, I am using a very simple architecture here. I will have an API gateway in the front end. There would be a Lambda function, and the Lambda function would be interacting with any number of AWS services in the backend. So let me just go on to the AWS console. So this is my console. Let me just log into my EC2 instance. So on this instance, to the prerequisites for using SAM CLI would be having AWS CLI, Docker optionally, as well as SAM CLI. So we can very easily download SAM CLI using pip command. Let me just become the root user. I hope the screen is visible. Let me zoom in. Yes. So I have already created one app yesterday just to test it out. But for you right now, I will create the app again. So the first command would be I want to create a sample application. So SAM, what it does is it gives us an option to deploy a number of sample applications for which SAM itself gives us the code. This will help us to understand the SAM applicability better. So now if I go with the SAM init command, as you can see, you can pre-select a particular runtime or a package type using SAMinit experience. So which template source would I like to use? I can use a custom template location or I can use AWS quick start templates. So these are the ready-made templates that we can use. So I will go with option number 1. So these are multiple options. These are multiple use cases we can use to simulate in our AWS environment using SAM CLI. So I'll just go with the first one, that is the Hello World example. So SAM asks us to use the most popular runtime and package type. What this would do is it will automatically set the runtime of our Lambda function to the most recent like the most recent deployed language. So for example, if my Lambda function uses Python, it would assign it Python 3.9. That is the most recent package for Python. So if I go with yes, and for X-ray, I'll currently go with no. I don't want X-ray tracing. It will ask me for a project name. So project name would be something by which my project would be saved here. Since I already have a SAM app here, I just give it a name called SAM and enter. So now what it will do is it will clone this repository here. As we can see in this repository, the code is already present. Yeah, and with multiple runtime languages. These are all the SAM CLI application templates. So as you can see now, our application has been generated and downloaded. So let me just list. So here, as you can see, SAM, this is what I created right now. So I'll CD into it. So this is what is inside my application. There is this is my application, that is hello underscore world. This is the SAM template and the other files related to my application. So let me just show you what the template looks like. This is what the template looks like. So there is resources, there is this hello world function, this is my Lambda function. Here I have defined certain properties for my Lambda function. As you can see, the runtime has been assigned to the latest, that is Python 3.9, and the architecture is x86. So for building this application, yesterday I ran into an issue. Your server on which you are running SAM CLI should have a Python 3.9 available. Otherwise, you will face a build error. So this is my application. These are the events. So here is where I create the API, gateway API, and method. And these are the outputs I get from my template. So it is the serverless REST API and the function name and the function IAM role. So now that we have everything in place, let me go ahead. So these are the set of commands that I'm following. We can provide this later as well. So now that I've cd'd into my application folder, I can do a SAM build. So what this is doing is it is building my application here. So it is building the code URI. It is checking for the runtime as well as for the architecture for my application. And it tells me here that my build was successful. And these are the build artifacts that I get. So there's a template.yaml and that /build file. Now it also tells me what commands that I can use next. So I can validate my template using SAM validate. I can locally invoke my function using SAM local invoke, and so on and so forth. So let me just validate my template. So I'll do SAM validate. It's as easy as that. So it looks for the policies. So this EC2 instance has an instance profile that is attached to it. So it looks at the policies and checks if all of the resources that are being created in my template, if I have permissions to create those resources. So it checks that, and it loads all the policies, and it tells me that my template is valid and it can be deployed. So the next thing that I can do here is I can locally invoke my Lambda function. So as I previously showed you, I can locally, instead of deploying an actual resource on my AWS environment, if I just want to quickly test if my code is working fine, I can just directly test my function here. So what this did was invoked my handler, my Lambda function handler, and it would pull an image. Since there is already an image for the runtime in my local, it is skipping this step. It would mount it, and then we would see this response coming from our Lambda function. So here I defined an event, right? Event slash event JSON. So this event would invoke this output from my Lambda function. So now I know my function is working properly. So now what I can do is I can directly go ahead and deploy my function. Before deploying your function, I would suggest you check your instance role here, or if you are using these commands from your local, you check your user whose credentials you're using, you check its permissions such that the CloudFormation template does not face any errors while deploying. So if I go now, if I do a SAM deploy guided, so it would ask me for a stack name. So I would give it SAM application stack. And it would ask me for a region. I'll leave it as the default US East 1 region. And it would ask me if I really want to deploy it. So if I say yes, so if I want to allow SAM CLI for IAM role creation, this is basically when you deploy a CloudFormation template, and if there are any IAM resources being created into it, it would at the end of it, before deploying, it asks us, right, using checkboxes, if we want to allow or acknowledge that our template would create some IAM resources. So this is similar to that. And we can also disable or enable rollback. So I don't want to disable rollback, so I say no. So it asks me if there are any authorizations defined. Is that okay? So I'll currently go with the default option and save arguments to the configuration file. So any arguments that I'm passing to my template, do I want to save them? So I'll say yes, I want to save them. So there would be a SAM configuration file that would be created. I would just go with the file name. This is the default file name. So I'll just go with that. And the configuration environment, I'm leaving that as default as well. So it looks for the resources that are needed for deployment. So there is an S3 bucket that was created where all of these resources would be stored. Let me just go back. Yeah. So this S3 bucket was created directly using SAM CLI, and my configurations were saved. So deploying the following values. So this is what I selected currently in the guided process, and it initiated my deployment. So here it, similar to the CloudFormation UI, it shows me all of these values, all of these resources that are being created, and it asks me before deployment, do I really want to create it? It also gives me this CloudFormation ARN, so I can go to the CloudFormation console. Let me just go there. and I can monitor my template. So currently I don't have a template, it is review in progress. Since I have not said yes here, I have not said yes to this, it is in review. So if I say yes, now my template will start deploying the resources. So as you can see, it is giving me these events here. It is more than enough to monitor my CloudFormation deployment. But if I still want a UI, I can go here and I can see that this template is automatically being deployed in the backend. So all of these resources are being created in my template. There's a function role and there's a function that is being created. So my function is now created. It is also created my REST API. Lambda permissions, API gateway stage has been deployed. And respectively, everything has been updated here. The outputs that I was mentioning previously, we can see here, see this, it gives me a REST API URL. So once my application is deployed, I can directly hit this URL and it would help me invoke my Lambda function and run my application. So as you can see, my stack was successfully created. Now if I go here, output here also you can see it has given me the value. So it has given me this URL here. If I go to this URL, it is a very simple application. My Lambda function is simply just printing this message. But as you can see, we didn't even have to navigate anywhere else but the CLI. I can directly access my application here. So now if I want to delete my application, what do? I don't have to go to CloudFormation and delete the stack here. I can just directly go here. I can do a SAM delete. And I can mention the CFN name. So here it has given me the stack name. So I'll just directly mention the stack name here. Ask me if I really want to delete it. I say yes. And if I want to delete the artifacts that were stored in the S3 bucket, and I also say yes. So it takes care of deleting all of this for us. So as you can see, if you are familiar with Terraform, this is somewhat similar to that in terms of the interaction on this CLI. So now it will delete the template for me. So if I go back to my CloudFormation template, see delete is in progress. So my template is being deleted and now it's deleted successfully. And it is gone. So this is how easily we can deploy and manage and locally render our serverless applications using SAM CLI. Before I move forward, are there any questions?
Yes, Aishwarya, I think there are some questions. So one of the questions what we have is from the Fargate section. If we want to
Yes.
communicate between task or services, do we have any options in ECS or developer needs to handle in code?
Yeah, the communication we can define. So for example, if my task contains, if my task architecture is such that there is applications container, and in one container I have my, sorry, let me go to the appropriate slide. Yes. So say if my task contains multiple containers, there is one container that contains my front end, one container that contains my back end, and the third container contains my database. So these containers would require to communicate with each other, right? So in the task definition itself, we can define certain ports that we can open between each of these containers so that they can interact with each other. And each task would contain of all these three containers.
Cool. Okay, Cool. I think that's what we have from the question. I think we can go ahead with the deployment. Thank you.
Thank you. Okay. So let me move on to our next section. Step functions. It is a very popular service provided by AWS. So what step function is basically, as you can see here, it is very easy to understand. There are certain steps in layman language. There are certain steps that we need to execute. If it executes successfully, then it goes through one path. If it doesn't execute successfully, it goes through another path. Or we can have multiple choices, 1, 2, 3, 4, and multiple branches to it. So for example, if you have an application that first goes to DynamoDB and it enters some value in the DynamoDB, and if that value is entered successfully, we send out a notification using SNS. So instead of writing the logic for interacting with these AWS services in our application itself, what we can do is we can use something called as a workflow orchestration tool. That is what step function is. So we can directly invoke an execution in our step functions, and we can provide an input using our application, and then we can forget about it. What step function would do is it would execute a sequence of fixed or dynamic steps in a sequence. So each of these steps could be invoking another function. It could be invoking a choice that we have to make based on the output from the previous step, and such that an workflow would be orchestrated, and whatever the output is in the end, it could be returned to our application. So how is using an orchestration tool better than using our application? What it does is it helps us modularize and make each of these steps as independent. So failure of one step will not cause a cascaded failure in our entire application. If a step fails, we can directly have some failure or a catch mechanism there, such that next steps are not affected or our application does not fail. It helps decouple our application. That is, none of these steps depend on each other for execution. I can define a rule here. Even if this step fails, this should execute. Or if this step fails, I can retry it 3 times. Or I can use something called as an exponential backoff if my service limit has reached. So therefore, there is something called a built-in retry mechanism that step functions provide. This helps us mitigate any sort of error during our application execution. So, what step function is, as you can see here, it is a state machine with some tasks. So, a state machine is a workflow. So, this is a workflow here. So, it is a certain amount of steps, and there is a flow here. There is for based on the rule that I have defined here. Each step in the workflow is called a state. So each of these steps are states, and each step can have something called a task. So task is something that can be executed once at least or more than once. And each task can be invoking another AWS service, or it could be using some rule to make our workflow go forward. So some of the use cases for using step functions could be machine learning models. So if I want to train a model, if I want to test that model, so I can do that easily using step function orchestration. I can also define retry mechanisms. I can also define certain paths for training. There is also glue ETL workflows. This is the most common use case for step functions, that are ETL workflows. So in ETL, there are a certain number of steps. It is not just one service that we need to target, as well as it can be asynchronous in nature. So in that case, we can invoke those steps step by step. We can also define a timeout. If my glue runs for more than say 10 minutes, then I can easily say that there is some runtime error that is happening, and I can kill that execution of glue. So using step functions, I can orchestrate a ETL workflow. I can orchestrate some long running processes. So if my application wants to invoke something long running in the background, that is syncing database tables or something like that, then I can invoke step functions in the backend. In this case, it is helpful because since Lambda has just a 15-minute timeout, using step functions, I can orchestrate a very long running process instead of just 15 minutes. Then there are automated workflows or applications that require human interaction that I'll be going into detail in the further steps. Yes, so here are the use cases that we can use with step functions. So very simple one would be a function orchestration. If I want to invoke certain Lambda functions, see in a sequential order, and pass the output of this function to the next function, this function to the next function, then I can use step functions. This would be in the case where the execution time is more than 15 minutes, so I need to invoke the Lambda functions again and again, or I need to invoke different Lambda functions. Then there is error handling and retry. So if I'm trying to say write to a DB and the connection pool is full, I can create a retry mechanism such that it then tries again after 1 second, it tries again after 3 seconds, so on and so forth, such that my step function will only move forward when I have successfully written to my database. On the other hand, I can also define number of retries. So it will only retry 3 times, and if it fails, then my step function would fail. Then there is parallel processing. So, for example, if I want to convert a video into multiple types of resolutions at the same time, I can use parallel processing with step functions such that I invoke multiple Lambda functions that convert my video into multiple resolutions. Then there is human interaction. So if there is a workflow, a certain type of workflow where you need a human to authorize the next step, there you can use a step function. So in your application, you cannot have human intervention anywhere, right? You cannot just say yes. Instead, in step functions, otherwise, when you have a certain step here where you will get some input from the previous step, you can manually read that input and you can then approve the next workflow. Instead of it being an automated process, there would be a human interaction involved. Then there is branching. So similar to what we saw in the previous slide, based on a rule that I have defined or based on the output from the previous step, I can have multiple ways this workflow could go. It could go to n number of Lambda functions. And then there is dynamic parallelism. So in case of streaming data, if I want to process it while it's being streamed, then it can be parallelly streamed in multiple parallel workflows using the same Lambda functions here. So it is being streamed, it is being transformed, that is an ETL job is probably happening here, and then it is being entered into some data warehousing service. So these are all the use cases that I have defined in a much higher level that can be used with step function. These can be used to handle very complex use cases, and we can also make it serverless, of course. So, talking about the various steps in a step function, what exactly do we do in a step? So, the most common use cases, we invoke some sort of an AWS service in that step. And these are all the AWS services that we can invoke using step functions. These are optimized integrations, and we can use AWS SDK as well to integrate with over 200 services on AWS. So we can use any of these services with step functions to create a serverless workflow. So how do we define a state machine or a step function? So there are two ways to do that. As I will show you in the walkthrough, we can either use the interactive UI that AWS has provided us with to directly create our workflow, or we can use something called as the Amazon states language. What this is a JSON based text that represents the structure of our step function. So there are some very commonly used fields that are there in this JSON format that I'll just describe here to you. Comment is just an annotation for a step function. Then start at is basically which state will my step function start at. So in states, what I define is a list of various steps. So as we can see here, these are all steps. So inside state, I can define all of these steps as their own JSON brackets. And in start at, I will define which step to start my workflow with. Then there is a timeout. I can set a timeout for each of my state. I can set a version. Then there is states, as I defined, is a list of my step function steps. Then there is type. So what type of a state it is? Is it a pass? Am I just printing something there, or am I calling an AWS service? So that would be a task type of state. So in a task, we can call an AWS service. We can perform certain actions, and then there are these two options, next and end. This is very simple to understand. So if I have two states, say hello world 1 and hello world 2, if I give a next here and I lead it to hello world 2, then after this state is easily executed, it will go to the hello world 2 state. And at hello world 2 state, I will define an end, which is if my workflow ends here. And if that is true, my workflow will successfully exit there. Then there is an input path and an output path. So if we want to pass an input to our step, we can define a relative path for our input and a relative path for our output as well for a particular step. So using that path, we can pass certain arguments to each of our steps. So I will go into the demo. So before I go into the demo, I can walk you through the console for step functions. Meanwhile, if there are any questions, please let me know.
Thanks, Aishwarya. So, yeah, there are two questions what we have, and these are for the SAM application.
Yeah.
One is Mohit. Can we start SAM application from AWS cross account, or we need to set up a AWS application accordingly?
Yes, we can. So what SAM is basically here, how I configured SAM was I used an EC2 instance within my account itself, and there I installed SAM CLI and I was able to access my AWS services. But what generally you would do is install SAM in your local computer. So how do you access AWS from your computer is using user credentials, that is AWS access key and secret key. So in those user credentials for your user, you can define a cross-account assume role definition. You can define your user to be able to assume role in a different account. And using those credentials, then you can use SAM cross-account.
Thank you. There is one more question. Is there a way to manage the number of step functions which can run concurrently?
Yes, we can. So from step functions also, I think, although I have never used such a use case, but with step functions, we can check here in the resource. If I go to edit and if I go to resource and I just empty it out. So as you can see, these are all the services that I can handle with step functions. Let me just scroll to S and T. So here are all the actions that we can perform with step functions. Yeah, so here I don't see that we can invoke another step function from this step function itself. But yes, there is a way that we can orchestrate the running of multiple step functions side by side, as well as we can do it such that we don't have multiple step functions in the same one. We can have parallel dynamic execution. So 3 different workflows are executing in parallel. So there are two types of offerings from step functions. One is standard and one is express. So in standard, we usually have just one time running long workflows, so long duration workflows where each step runs only once. Whereas in Express, we can run each step at least once. So we can run these steps parallelly. So instead of having multiple step functions, we can have just one, or we can orchestrate how to run multiple step functions as well.
Thanks. I think last question, similar to the step function, doesn't the human interaction cause a bottleneck?
It would, yes. But then again, we can use that human interaction only if our application really requires that. So, if there is something that reads manual approval in your application, then you invoke a human interaction type of step function. Otherwise, you can have a completely automated workflow.
Yeah, thanks. And also, just to add what Aishwarya mentioned, I've seen different patterns where people try to capture this authenticated URL via Lambda, give it on email, Slack, and those kinds of channel. So you really don't have to get into some actual human login into the console and approving it. You can provide device friendly kind of an approach and try to minimize the dependencies or a blocker.
All right. Yep. Moving on with our walkthrough. So step functions, this is the console for step functions. Here you can see I have one. So if I go to create a state machine, these are all the options that are provided to me. I'm going to use the term state machine and step function synonymously. They mean one and the same thing. So I can either create a workflow visually, I can write the code for my workflow using AWS state language, or I can run a sample project. So if I go to sample projects, as we can see, step functions provide us with multiple sample projects that we can use here, that we can then invoke to understand this workflow, or we can create a sample project and we can modify it based on our requirement. So currently, if I go to the workflow, designing the workflow visually, as I told you, there are two types of offerings. There is standard and there is express. So express is event driven streaming data processing workflows, whereas standard is durable long running workflows. So if I go with standard, here you can see this is the design UI. I can directly pull something and place it here. I can define all of the configuration here, and I don't really have to use the state machine language. At any point here, I can just use this interactive UI to create my workflow, which is very simple, very easy to do. I can also define input, output, error handling for the same. So there is a retry mechanism that I can create. There's a catch mechanism if something fails, or do I catch it such that my next steps don't fail. There is timeout and there is heartbeat. So if I go back, leave, I have manually written some code. So let me show you that. So if I go to my state machine here, and if I go to the definition of it, let me just zoom in. So this is my state machine currently. It is a very simple help desk use case where this state machine is invoked when we need to open a case in help desk. So we open a case, we assign that case to someone works on that case, and then we check after working on that case, was the case resolved. If the case was resolved, then we close the case and we send out a notification using SNS. If the case was not resolved, then we escalate the case and we fail. So these steps are very self-explanatory, but on each step, I am invoking a Lambda function. This Lambda function would do certain processing on the back end and return some output to me, and I will move on to the next step. So in the definition, this is the comment, this is the annotation for my step function. So I have defined start at open case. So my step function starts at open case. And these are all my states. So open case is the first state. It is type task. So here we can perform a task. So the resource, in resource block, I can directly either define my Lambda function ARN, or I can define something called as Lambda invoke. So if I go here, 1 second, I'm not in edit mode. Let me go in edit mode. So if I go here and if I see, I can invoke my Lambda function. So I can just define Lambda. And I can do multiple things other than just invoking a Lambda function. I can add layer, I can add permissions, create alias, delete a function. All of these things I can do with Lambda. So if I just select Lambda invoke, and then after this, I can define a block called properties, where I can define which function to invoke and what are its parameters, what is the timeout, what am I passing, what is the payload. I can define all of that. But to make this simple, what I've done is I have currently just given my Lambda ARN here. So it directly invokes my Lambda, passes on the input, and saves the output. So here I've defined the next. Next means after this state is executed, where do we go? So next we go to assign case. And similarly, we move through the process. Now coming to is case resolved. So my work on case would do something such that it would find out if my case was resolved or not resolved, and it would pass on that output to my next step. So in case resolved, I will check the value of this variable called status. This was an output from the previous step. It would check this value, and if it is equal to 1, then it would close case. 1 means that the case was resolved. Then it would close my case, and after my case is closed, I will publish to SNS. So this is a different type of step here. Here in the resource, I'm just defining publish for SNS. I can also have multiple SNS functions as well. Here I'm using just publish. And as I said, we can define a parameter block where I can define my topic ARN, which SNS ARN to use, and what message I want to pass on. So this message again is an output from my previous state. It will come to me and I will just email it to the respective SNS topic. And in case my status is 0, then it would escalate the case. So in escalate case, I will just invoke another Lambda function here. It would do whatever process is required in the backend, maybe make some changes in the database, and it would go to the fail state. Fail does not mean my step functions have failed. It just means I have created a step here where I am explicitly defining this whole workflow to fail because my case was not resolved. I could also send another SNS publication here, but this is the workflow that we are currently working with. And I have created a Lambda function as well. So let me go to that function. Currently, I am handling all of these steps using the same Lambda function, but there can be multiple Lambda functions here. Yeah, this is my Lambda. So as you can see in the code, here I am handling each case here, but these can be different Lambda functions as well. So for the ability to understand, I'm just going to open the Lambda logs as well, and we're going to check the step functions log as well. So let me just invoke an execution in my step functions, start execution, and we pass some initial input to the first step. So this is my input. This is the input that I'm passing. So the case that we need to open and the state we need to start. So open case. And I do start execution. So as you can see, my state machine has already executed. Let me just zoom in. And my case was not being able to resolve. So due to the logic that I have written on my Lambda function, I passed a 0. That is, my case was not resolved. So it escalated the case and it failed. Here we can check the event execution history. So this is how the step function executed step by step, and we can check the logs also. So this is the input that went in my first step, and this is the role that my step function is using. So it execution started, task state entered, my lambda function was started. It gave me some output. This is the output that came from my lambda function, and so on and so forth. We can also check the CloudWatch logs here for the Lambda execution where I am already here. So this is the execution that we currently invoked. One second. Let me just refresh this. Yes, this is the execution that I invoked. So if I go in here, I can see the logs. So my case was opened, my case was assigned, it was unresolved, and then it was escalated. So now if I run my state machine again, one second. Yes. If I run it again and see if my case would be resolved this time, go to my step functions. This time my case was resolved. And as you can see from publish to SNS, I was able to get an email through SNS that my case has been resolved. So let me show you that email. So if I refresh here, in the same thread, I will get another email that my case was closed. I may have to open my inbox to show that email, but yes, I received that email, as you can see here. I received an email that said my case was closed. And here in Lambda CloudWatch logs also, I'll be able to see that. So since this was executed in the same time range, in the same log group, I can see that my case was closed. So are there any questions on this workflow?
Nope, I don't see any questions so far. Would request all the audience to please put the questions in the chat so we can take it up. And I see there is one question. Uh, can we use KMS encryption in step function when one
Yes.
step output is passed to another state? Is it encrypted?
Yes, we can use KMS encryption as well. So when we are defining our state machine, we can use encryption. We can also fetch values from various services such as secrets manager or parameter store, and we can encrypt our inputs as well as our outputs with step function.
Thank you. The next question is, what are the ways to invoke step functions?
So a step function can be invoked same as how lambda function can be invoked. We can use event-based trigger to invoke a step function. We could also use AWS SDK to invoke a step function and pass it an input. So it's very similar to how you would invoke a lambda function.
Thank you. So yeah, I would request all the audience please to post the question in the chat. And yeah, as I mentioned in the chat, we do have a quiz coming up post this demo. So please stay tuned. This is not the end of the session. We have many more interesting things coming up. So yeah, we'll take a couple of minutes. If you guys have any other questions, please put it in the chat. Aishwarya and I'll be happy to answer. And then I'll pass it on the control to Abhishek and Pushkar so they can help you with the quiz. We need to do a couple of setups, so they will help you to the setuping the things, and then we can start with the quiz. So I can see a question. Step function only works with serverless service, or can we use EC2 or ALB?
As far as I am informed, that we can use step functions to also run something called as uh, something on EC2 as well. So we can launch a task on EC2 server that needs to run, and using step functions we can invoke that as well. But the whole point of using step functions is that it is serverless, so it would be very efficient to use it to orchestrate various serverless services together.
Yeah. And also to add what Aishwarya mentioned, right? If we see from an integration perspective, which I think Aishwarya just ran through that list a few minutes back, there are many other things like glue job you talk about, EMR cluster deployment you talk about. Those all things also you can do. So, I mean, ideally, yes, as it's effective for serverless, but not just meant only for serverless. It's more of an orchestration which can help you for deployment of any machine learning or big data processing kind of platform too. If there is any other questions, please put it in the chat. Okay, so uh, yeah, I think that's what we have from Aishwarya. Thank you, Aishwarya. I would still request to you to continue the session as we have quiz from Abhishek and Pushkar. But thank you so much for that interesting session. It was really good. And I think I can see a couple of feedbacks coming out in the chat that people do like the sessions. It was backed up with good demos. So thank you so much for that. And guys, as I mentioned, this is just the first session. We have three more lined up, and our speakers are very good. They are renowned for their knowledge in serverless. You can see Jonas is already part of the audience, who is the speaker for the next session. So yeah, I'll give you the details, the brief, what is the next session, the topic, and the timing. But yeah, stay tuned. We'll have more session. With that, let me pass it on the control to Abhishek and Pushkar. So they will help us to set up the quiz and make the session more interesting. Yeah, Abhishek and Pushkar, you're live. You can just give the instruction to the customer, to the audience, and we can take it from there.
Thank you, Sanchit and Aishwarya. That was a great session.
I hope you guys all
So,
enjoyed
hi
it.
everyone. Yep. So, myself Abhishek, I am organizer at AWS User Group Nashik, and along with me here we have Pushkar, who is also a co-organizer at AWS User Group Nashik. So, I would request Sanchit to post the quiz link actually in the chat, so that people can join the quiz. Before getting started with the quiz, we have some instructions. So you will get a quiz link in the chat. Okay, so you will have to log in on the Quizzup platform, and you will be able to see the platform. And once we roll out the questions, you will be able to see that also.
It will be basically a simple thing like a normal quiz you guys game, like MCQ kind of. And we have after this quiz, we'll show the leaderboard and we'll contact you by your email. So for AWS credits, top three winners will receive the AWS credits. Yeah, we'll post our LinkedIn and other credentials in chat. So yes, after you complete the login, just give us a thumbs up in the chat, so we'll understand you completed the login process.
Yes. Also, there are few instructions for a smooth experience of the quiz. We recommend using Google Chrome so that nothing breaks in between for you guys. Apart from that, if you guys are using VPN or some network blocking services, please disable that so that we make sure that nothing else breaks while playing the quiz. Apart from that, if you feel you are stuck or something's going not working for you guys, we recommend using we recommend quickly log in back as soon as possible so that you don't lose any progress on the quiz. And please try avoid refreshing your tabs continuously while quiz is going on or question is being displayed. So that might ruin your experience while playing the quiz. Yeah, and also it will be just a simple multiple choice questions. There are in total 5 questions, all MCQs, and it will have almost 15 seconds for you guys to answer. And once the quiz will over, you can the same quiz link, you can see the leaderboard, your position, where you stand among all the participants. And once the quiz is over, we'll allow some time after the session to see the leaderboard get refreshed, everything is okay, and then we'll contact you through your email IDs, and we'll award you with the credits. So top 3 participants, top 3 people in the leaderboard will get the AWS credits. And yeah, we'll connect you after the session so that we can give you the credits. Let us know if you face some issues in the chat. We have Pushkar, Sanchit, and myself to resolve those issues. As of now, I can see there are 3 participants who are logged in. Also, there might be some sort of delays, so please bear with that. So whoever is able to log in and already logged in, please post it in the chat so that we will know that you are logged in. We'll give a couple of minutes more, and then we will start with our quiz.
I would urge everyone, please do join the quiz. As Abhishek just mentioned, there are AWS credits for the top 3 winners. So please do register and join the link now.
So I can see 3 of us join.
Yeah. Okay, now I can see there are 6 participants. So if you are trying to log in yet or in the process, please let us know in the chat, because once we start the quiz, it will be, it will get started and you might miss some questions. So if you are still logging in, please let us know so that we can wait a couple of more minutes. And okay, 30 seconds more and I will start the quiz.
So, guys, who just joined, I'm flashing the link of the quiz on the screen. It's https://quiz.conhub.com/q/sls1. So please do log in now so we can start the quiz.
So I think we will start the quiz now. And whoever logs in after that, you might miss some questions, but you can still continue. So now on your screen, you'll be able to see the first question in next 5 seconds. Yeah. And the time's up. So you can see the stats for the particular question in the chat. I see that 2 participants have given correct answers. Yeah, now next question coming up in next 5 seconds.
Yeah, so leaderboard will take a few seconds to refresh.
Yes. So I think time's up. So you should be able to see the stats for the leaderboard. I see there are 5 participants who have given the correct answer, which is great. So we will be moving up with the next question. Yes, as I mentioned, the leaderboard might take some time to refresh the entries, but don't worry. As you give answers, it will track the correct data. Yeah, I can see there are 6 participants who have given this answer correct. So moving on to the next question.
Great, the correct answer number is increasing.
And just to make it more interesting, there are only 2 more questions to go. This is the last second one.
Yes. Yeah.
And we have only 3 winners. So fuck up guys who are on the 4th and the 5th section. 2 rows, please.
Yeah. So
Okay.
Sridhar is on
I
top.
think so. 4 participants given correct answer for this question, which is almost 50%. And the last question is coming up on your screen. So here you go.
Yeah, Radhika Mahindra, you have chance to come in top 3.
Yeah. Last 10 seconds. Oh. The time's up, and I can see 7 participants have given correct answer.
So we are done, I think, with all the 5 questions, right?
Yes, so we are done with the questions, and the leaderboard will be still refreshing in the background, so it will take some time. But the players who are playing, they can see the live real-time data of their, if they have given correct answers or not. But it might not reflect it here in the quiz metrics on the screen right away, but it will be. And on the same link, you will be able to see the leaderboard once the session is over. So we'll be still giving few minutes after the session to settle down the leaderboard, and once we have that, we'll connect with top 3 winners, and we'll award them with the AWS grades as mentioned. So yeah, that was it from the quiz part.
Yeah, so
Thank you, Abhishek.
we are hoping you like the session, and we have many more to come. So stay tuned and follow our social media handles. Yeah, something.
Yes, as it stands, actually, so as it stands, Sridhar Kasukurti is on top of the leaderboard. Then Sushant is on the second, and G Sridhar is on third. But still, we'll wait for some time to get it refreshed, and you will be able to see the stat afterwards on the same link also.
Yeah, Abhishek. So you're
Yeah,
right.
I think
So the
we are done.
first,
Yes.
exactly, the first one is the first winner for the quiz is Shushant Kode.
Okay.
The
Okay.
second winner, what we have, who has answered the four right questions out of five, is Mahendra Tirumula. And the third one, who answered four questions again, but just missed by a couple of milliseconds, I would say, is Sridhar. He also answered the four questions, but I think from a timing perspective, Mahendra was faster. So Mahendra holds the second position and Sridhar is on the third. So here are the three winners what we have from sessions. Guys, we have your email ID,
Yes.
and if not, please reach out to me or Abhishek on our on our LinkedIn channels, LinkedIn IDs, and we'll ensure that you get your credits as soon as possible, and we can take it from there. So that's what an interesting session what we had outside in the four series session what we have. This is our first session. I hope you liked it. We saw a couple of good feedbacks. I would request all and urge everyone to please continue your participations for the remaining three sessions. The next session will be after 2 weeks, which will be hosted, and the speaker for the session will be none other than Jonas, who's very renowned when it comes to serverless, and his involvement in serverless across AWS community. So Jonas will be the speaker for our next session, and we'll take it from there. Thank you so much for being a wonderful audience, and I look this active participation in the next session. Thank you, and stay safe.
Yes. Thank you, guys.